All right, so for example 4 here, we want to see if we can identify something as being a perfect square trinomial. So if we see these three terms, we want to say, can we pick out the idea that this indeed is going to be factorable into a perfect square? So what were the things that we need to know? Well, we need to know, is the first term a perfect square? I would say yes, 4j squared. You could get that by doing 2j, that whole quantity squared, right? So if I take 2j times 2j, I would get 4j squared, meaning the first term is a perfect square. It's a perfect square with a side length of 2j. Okay, what about that second term? Is it equal to the square root of the first one times the square root of the second one times 2? Well, we've got the square root of the first one here, 2j. We've got our times 2 part. And what's the square root of 16? Well, that would be 4. So yes, looks like we check off that one. Everything looks good. Now, was that last term a perfect square? Yes, it was. 16 can be drawn as a square with side lengths of 4 times 4. So we say yes. Okay, since this trinomial does not satisfy all conditions, it is not a perfect square trinomial. Uh-oh, what's going on there? I'm not sure why I see why they're saying that. Oh, I see where my error is. Okay, do you see where my error is? Can you look at that and see what we got wrong? So did we get the first one wrong, the second one wrong, or the third one wrong? So let's look closer at that second one, because I'm seeing something different now. Is the second term equal to 2 times 2j times 4? So this is correctly written. This is what we want the second term to be equal to, but is it what the second term is? Well, if we multiply 4 times 2j, we get 8j, and if we multiply that by 2, we get 16. So no, we do not get 16j. We only have 8j in the middle. So therefore, no, this one is not a perfect square trinomial. If you saw that before I did, great job, good catch.